Hello, good evening everyone. I welcome all of you to the most comprehensive exam prep app, that is BYJU'S Prep app. I welcome everyone for the IIT Kharagpur GATE Soil Mechanics questions previously asked in GATE examination. All of you please join fast. And let us start the previous year questions asked by IIT Kharagpur for the soil mechanics. We have already seen the strength of material, then fluid mechanics questions, and today we will see the soil mechanics question for. So all of you please join fast. All of you please join fast. Okay. So without delaying, I think we should start now. And please do not forget to like and share, right? Please like those who are here. Please do not forget to like. Hello Shiana, Sanatam, Priyadarshi. Yes, good evening everyone. Okay. So this is my introduction, as you know, and you also can join me on Telegram channel, that is Civil by Ansari sir, right? Once again. So here okay, here is the star faculty of our BYJU'S Prep, and these are the different type of courses which are running on, that is for Vision GATE 2022 rank up, and there is a Vision 2023 batch also going to come. Those who are interested can join. It will be very beneficial for all of you. So here is the first question for all of you. Generally, if you'll see, before starting the question, I would like to discuss about the soil mechanics, what kind of questions they have asked. As I told you, for the strength of material subject, mostly, see, one cannot predict exactly, but one can say that yes, if you see and if you go through the previously asked question, and from previous questions, one can say that, and I told you already that deflection were the most favorite chapter for the IIT Kharagpur. Now here it is not something like that. Almost from each and every chapter they have asked. If you will go through each of the chapter for the soil mechanics, they have asked from each and every chapter. They have never skipped any one of the chapter here. So complete soil mechanics is, you can say that it is important for IIT Kharagpur. So here is the first question. A given cohesionless soil has a Emax and E minimum has given in the field. The soil is compacted to a mass density of 1800 kg per meter cube at a water content of 8%. Take the mass density of water as 1000 kg per meter cube, and GS also given. The relative density he is asking. You know that what is the formula for relative density, isn't it? So formula for relative density already you know that is nothing. That is nothing but Emax minus E divided by Emax minus E minimum. Now Emax and E minimum already has been given, only the void ratio we supposed to calculate, isn't it? And for the void ratio you can see that they have given actually the mass density at a water content of 8%. So from that mass density what they have given, from there you can calculate the dry density, isn't it? That gamma has been given, that is 1800 divided by 1 plus the water content has been also given, which is 0.08. If you calculate, you will get almost around 1,666.67, I think, right, kg per meter cube. That is the dry density. Once you will get the dry density, you know that how to calculate the void ratio, isn't it? The void ratio can be calculated by using the formula, that is gamma D equals to G by, you already know that G plus ES, when S will become 0, right? S will become 0 and simply G by 1 plus E into gamma W. Now 1 plus 1666.67 equals to G value already given 2.7 divided by 1 plus E divided by 1 plus E, and here you have 1000 kg per meter cube for the water. And fortunately, if you calculate from here, the void ratio you are going to get around 0.62. Once you will get the void ratio once you'll get the word, yes, Satnam, absolutely correct. And those who have joined here, please do not forget to share the session, isn't it? So put the value here and you'll get, so Emax is given 0.85, 0.85 minus 0.62, which you have just now calculated, and then once again 0.85 minus 0. E minimum is 0.5, and in terms of percentage, if you'll calculate how much you're getting it, you're getting almost around 65.7%. 65.7%. These are just normal questions from the first chapter, and first chapter is basically whatever or wherever you will go in any of the examination. This first chapter of the soil mechanics is quite handy and useful, right? Go back to the next question, forward to the next question, that is, a certain soil has the following properties given. The degree of saturation of the soil, he is asking. How you will calculate the degree of saturation? It is quite simple, isn't it? ES equals to WG. But for this, E is not known to us. So you can calculate the E from the porosity as they have given, isn't it? Porosity they have given 40% by using the porosity value, that is 0.4 here by 1 minus 0.4, and that is 0.4 by 0.6. You can keep it as it is if you want to do the calculation further, maybe. So he's asking about degree of saturation. So S will be nothing but water content is given, that is 0.2, and 20% water content, and G value also they have given, which is 2.71, isn't it? 2.71 divided by 0.4 by 0.6. If you'll calculate, please let me know how much you are getting it. What is the value you are going to get from here? The value you are going to get almost around 81.3%. 81.3%. As they have asked, rounded off to the nearest percentage, means they are not willing to take any of the decimal, right? So rounded off will be 81%, isn't it? Rounded off will be 81%. Did you get that? Okay, go to the next question. Yes, Rahul, you did the calculation. I can tell you, you are getting 80.89. You know why? Because you calculated the value of 0. I'll tell you. I actually would like to tell you this one. 0.4 by 0.6. If you'll calculate here now, and if you write down the value, like some 66.7, whatever, 0.667 or something like that, then in that case you are going to get that value 80.89. If you'll keep it as it is, no, the way I kept it, you'll get 81.3. The next question is, soil sample has a void ratio of 0.5 and its porosity will be close to. That is too easy, isn't it? Just now we have solved. The porosity void ratio is given, and he's asking about the porosity, that is E by 1 plus E. That's all. 0.5 by 1.5, that is 0.5 by 1.5 will become simply 33.33, and that's 33%. Next one. A borrow pit of soil has a dry density of 17 kilonewton per meter cube. How many cubic meter of this soil will be required to construct an embankment of 100 meter cube volume with a dry density of 16 kilonewton per meter cube? With a dry density of 16 kilonewton per meter cube. So based on the dry density, he's asking about what is the volume you need to take it out from the borrow pit, isn't it? That is 100 meter cube of the embankment volume you need to fill. So you must know one thing, that dry weight of the soil will remain same, right? If dry weight of the soil will remain same, I can tell you that you can write down for the embankment purpose, and the soil you are going to take it from the borrow pit, right? For the embankment, if I write down that dry weight of the soil is nothing but, see, weight is nothing but your unit weight into the volume. So that is the unit weight, dry density gamma d1, that is that one. Okay, let me write down any value. So 1 I'll just provide, and the gamma d1 and volume of 1, and here also weight of the dry soil will be gamma d2 and volume of 2, right? For the embankment, already the gamma d and volume both has been given. If you see the gamma d for the embankment is given as 16. So both the weight, if you equate, you'll get 16 into the volume is 100, must be equals to gamma d2 for the borrow pit is given as 17, and 17 into V2. This volume we don't know. That is what they're asking. Hello Swamijit, after a long time, huh? So volume 2, you will be getting around, if you calculate from here, how much you are going to get? It's almost around 94 meter cube, I think. 94.12 you will get. That is around 94.12 meter cube. Yes, good afternoon. Now, next one. As per Indian Standard Soil Classification System, an expression for the A line. This is too easy. Maybe you cannot expect another. You know, they are not going to ask any other type, right? This is too easy. Almost everyone knows that. A line, almost everyone knows that. 0.73 WL minus 20, that's all, isn't it? Laboratory sieve analysis was carried out on a soil sample using a complete set of standard IS sieve. Out of 500 gram of soil used in the test, 200 gram was retained on IS 600 micron sieve. 250 gram was retained on IS 500 micron and micron sieve, and the remaining 50 gram was retained on IS 425 micron sieve. The coefficient of uniformity. The coefficient of uniformity. What is the formula for coefficient of uniformity? I hope you know that. Coefficient of uniformity, that is D60 by D10. The size of the sieve by which 60% of the soil is finer. 60% of the soil is finer. And D10 is the size by which 10% is finer. 10%. It's not U line, it's A line. Where is U line? I told you A line, I think. Santu. That was A line. So here D60 by D10 you need to calculate. First of all, see, 500 gram soil has been taken, and in a 600 micron, when the sieve size is 600 micron, and another sieve size you have 500 micron, and then you have another one 425 micron, right? 425 micron. The soil which is going to retain over 600 micron was 200 gram here. The 200 gram was retained on IS 600 micron. So 200 is going to be retained here. 200 is going to be retained here, and then 250 is going to retain over 500 micron, and 50 gram is going to retain on 425 micron. Now if you'll see what is the soil which is passing from these microns, these particular size of the sieve, what is the soil which is passing by, right? So passing from the 600 micron sieve will become nothing but 300, because total weight of the soil was 500 gram. Out of that 200 is getting retained, so 300 will get passed through. Then if 300 will get passed through, what is the weight of the soil which is passing from the 500 micron sieve? From the 500 micron sieve you have 50 gram which is passing from 500 micron sieve, and from 425 micron sieve 0. So percentage passing from these particular sieve size, if you will calculate how much you are going to get. The percentage passing, if you will calculate from here, see, 300 is passing out of 500. Out of 500 gram soil, 300 is passing. So 300 divided percentage passing. Percentage passing, or percentage finer than 600 micron. Percentage finer than 600 micron size. So if you calculate that, 300 divided by 500, so 300 by 500 divided by multiply by 100, how much you'll get? What is the percentage? 0 0 jayega 5 60%. And for this one, 50 by 500 into 100, and you'll get, this is 5. You can understand, I generally, okay, and you'll get 10%. Fortunately, D60 and D10, you have that 60%. See, what is the size by which 60% is finer? What is the size by which 10% of the soil is finer? Fortunately, we are getting this, directly that D60 and D10 here. The D60 will be now your 600 and D10 will be your 500. So, coefficient of uniformity will become simply 600 by 500, that is 1.2. That's all. 1.2. Next one. Laboratory sieve analysis was carried out on a soil sample using a complete set of standard sieve. Same question here, and he's asking the classification of the soil. It is the same question he's asking about the classification of soil. Now, if you see carefully, do you have any fine grain? See, if you'll see from 75 micron, you don't have a soil which is passing from the 75 micron. All the 500 gram, whatever the soil you have taken out, has been retained all over at 425 micron. See, not even a single particle is passing from that 425 micron as per the question he's saying. So, of course, we don't have any fines. We don't have any fines. Now, it will be the classification wise. If you see, now we have to classify either it will be gravel or sand. That too, we'll have to see that whether it is a poorly graded gravel or poorly graded sand or whatever it is. Well graded, poorly graded. Now, but it is sure that it is a gravel or sand. Now we will decide whether it's a gravel or sand. If you see carefully, all the soil get retained between 600 micron to 425 micron. And the sand starts from 4.75 to 75 micron. 4.75 mm. 4.75 mm. It means it has a huge range, and all the soil is actually falling in the sand position. All the soil is falling in the sand position. So, of course, it is a sand. Although if it is more than 50%, we are going to give a name for the sand only. Isn't it? If it is more than 50%, we are going to give the name for the sand only. But it is all the soil is coming to the sand category only. No gravel we have. So, because all the soil we have is in between 4.75 and 75 micron, or I can say that 75 micron you want to write down, or just you write down in terms of mm, it will be 0.075 mm, right? So it is a sand. Now we have to decide whether it's a well graded or a poorly graded kind of thing. If you'll see that coefficient of uniformity already we have calculated, and as long as the coefficient of uniformity for the sand, if it is less than 6, it is your poorly graded sand. Of course, it is less than 6. That is 1.2 only. 1.2 only, isn't it? Yes, Monica, absolutely correct. Babu, you are also correct. Yes, 1, 2, 3 CU ranges for well graded. Yes. So now you can say, what is that? It is a sand, although and poorly graded sands. That's all. SP. So that is the kind of categorization here. Next one. Which of the following statement is not true in the context of capillary pressure in the soil? This is one kind of question. Actually, the modified questions already I used to prefer. Huh? Sometimes maybe those who are actually following me, they know that some question related to that when the water will be under tension, right? That question I usually used to bring. This time also it is appearing, but in the different format. So here, which of the following statement is not true in the context of capillary pressure? Water is under tension in the capillary zone. See, it is not about tension and compression. It is generally, it is okay. Water is generally tension in the capillary zone. So whenever you have a capillary zone, water will be hanging and it will be under tension, isn't it? Whenever you have a capillary zone, water will be hanging and it will be under tension only. That is actually correct one. Then pore water pressure is negative in the capillary zone. Yeah, I was talking about this one. Pore water pressure is negative in a capillary zone. You understand one thing, that negative and positive is quite different strategy. See, it is not, this is a general question. In strength of material, generally we are recognizing when we are applying the force, we are saying that tensile force we are, we are considering as a positive one, and the compressive one we are considering as a negative one. But for the soil and water, have you ever seen that the water is like, can you say that someone is hanging with the help of the water, isn't it? You can hang with the help of the rope. You cannot hang with the help of the water, isn't it? So generally all the compressive force has been considered as positive and the tensile force has been considered as negative. So whenever they are talking about that pore water pressure is negative, negative means yes, of course it is in tension, then it will be negative, all that's all. So both the sentences are actually same. Pore water pressure is negative in the capillary zone, or you say that water is under tension in the capillary zone. Both the statement are same only. What do you say? Both the statement are same only. Where is the difference? Where is the difference? Both are correct only. Effective stress increases due to the capillary pressure. Yes. If you have a capillary zone, effective stress increases. Why? Because it is the effective stress we are writing down is total stress minus pore water pressure. Once your pore water pressure will become negative in the capillary zone, so minus and minus will become plus and your effective stress certainly will get increased. This is also true. Only the last one, the capillary pressure is more in the coarse grained soil, is the wrong one. Why? Because for the coarse grained soil, you will be having larger dia of, pores will be there. Larger dia means the retentivity, they cannot, the rise of the capillary of water will be very less in the coarse grained soil. So less pressure will be there. That's all. In a coarse grained soil, the capillary pressure will be less. So this is the one which is not correct. So as per the answer, yes, this will be the correct one. Matlab, the wrong one which he is asking about. Did you get that? The range of void ratio between which quicksand condition occurs in the cohesionless granular soil deposit. So you already know that the quicksand condition when it occurs, right? The hydraulic gradient, it is based on the hydraulic gradient. When your hydraulic gradient, what is that hydraulic gradient you have? Which is the critical hydraulic gradient, G minus 1 by 1 plus E when it becomes 1. And from here you can calculate it. It is quite easy question. You can just put G value, they have not given. Granular soil deposit. So G value you take it as, or maybe you can take 2 point, I don't know whether it was given or not. So take the value of G, maybe around 2.67 or 2, generally it used to be 2.7, 2.6, something like that. So 2.67 minus 1 divided by 1 plus E equals to 1, and if you calculate from here E value, you will get from something 0.67. So it ranges from 0.6 to 0.7. It ranges from 0.6 to 0.7. Yes, Santu, absolutely correct. To provide the safety against piping failure, once again same type of question. Once again same type of question. Those who are here, please do not forget to share or like the session. All of you, please like the session, right? So this is same type of question, isn't it? Same type of question. Why? Because he's asking about what must be the permissible exit gradient. So first of all, find out what is the critical gradient. So the gradient here is nothing but, if you calculate how much you're going to get, so G minus 1 divided by 1 plus E, and this time G value given. Yeah, this time they have given 2.5 minus 1. 2.5 minus 1 divided by 1 plus void ratio they have given. They have not given void ratio. You can calculate the void ratio. What is the problem? They have given the porosity. From there you can calculate the void ratio, that is 0.35 divided by 1 minus 0.35. How much you are going to get? That is around 0.538, I think. 0.538, 0.538. Put the value of 0.538 here, and you get the how much you are going to get from here. What is the value you are going to get? That is 0.97. So now 0.975. This is the exit gradient you have. Now, if this is the exit gradient and he is saying that consider the factor of safety of 5. By considering factor of safety of 5, you cannot allow the exit gradient to be, so the permissible one will be, permissible gradient will become 0.975 divided by the factor of safety, which is nothing but 0.195, right? But generally, if you see whatever the question I am solving it, what do you feel? All are very general question asked from each and every category of the chapter, isn't it? Solving previous year question, what exactly you are looking forward? The solution, no. It's not about the solution. See, solving previous year question is kind of just going through what kind of question they have asked in the previous past when they have conducted the GATE examination for 2000, then 2006, then for 2014. What type of question they used to prefer to ask in the examination? That's what you are going through. And by seeing that all, you will observe generally very genuine questions they have asked. Matlab, you can imagine that if you are really preparing for the soil mechanics, if you are good in your basic concepts and fundamental, right? Then some of the formula, if you can remember, although it is very necessary you to remember that one, then it will be quite effective to get the marks at least from the soil mechanics portion. So you can effectively get the marks from the soil mechanics question. This one, once again, this is a typical type of problem. There is nothing in matlab this type of problems whenever they are asking, it is same category. See this question, no, without seeing also, once you'll see that flow net has been occurred, flow net, once the flow net you will see, you will simply write it down. Array, whether he is asking or not, maybe I'll require that. No, discharge is what? KH, I'm sorry, discharge is that KH, the permeability, hydraulic head, and number of flow channel, then number of potential drop. That's all. That is what you are going to write it down. What else? Now calculate. Simply you calculate. He's asking, now you read out the flow net constructed for the damage shown in the figure below, taking the coefficient of permeability. They have given SK. The quantity of the flow, of course, he's asking about the discharge now. He's asking about the discharge, quantity of flow under the dam per meter. And he's asking in centimeter cube per second. Okay, let it be centimeter cube per second. So calculate number of flow channel and number of potential drop here. What is the potential drop? These are all potential lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So potential drop from one to another. 1 minute कितना calculate किया मैंने? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. So you have 11 lines. So total potential drop, if you are talking about, there is one drop, second drop, third, fourth, fifth, sixth, seventh, 8, 9, and total potential drop during the flow is 10th drop. That's all. And number of flow channel, if you see, there are only 3 channels, isn't it? 1, 2, and 3. That's all. Only number of flow channels are only 3. That's all. So just keep the values here and calculate. That's all. So it is given as 3.8 into 10 raised to 3.8 into 10 raised to minus 6 multiply by what is head? What is the hydraulic head? Right, head, if you see, this is 6.3. that's all. 6.3. 6.3. Can you see that? 6.3. Then number of flow channel you have 3, and number of potential drop you have 10. Acha, one more thing you should understand, this is in meter per second, and this one also you are going to get that 6.3 is in meter, right? So the Q value, the discharge value, you are going to get a meter cube per second. So calculate what you will get. Meter cube per second you will get, isn't it? Meter cube per second per meter you will get that is 7.182 10 raised to 7.182 10 raised to minus 6 meter cube per second. He's asking in centimeter cube per second. So let it calculate in centimeter cube per second. 1 meter is equals to 10 raised to 2 centimeter. So it will become 10 to the power plus 6 if I want to convert it in centimeter. Minus 6 plus 6 will go off, and finally you are going to get 7.12 centimeter cube per second. That's all. That is what I was saying. See, these type of questions, whatever you have, they are quite easy. They are not as so. Next one, what is flowing at a steady rate through a homogeneous and saturated horizontal soil strip of 10 meter length? The strip is being subjected to a constant water head of 5 meter at the beginning and 1 meter at the end. If the governing differential equation of the flow in the soil strip is d square h by d square, where x is the distance, the value of h in meter at the middle of the soil. So water is flowing at a steady rate. Steady flow is there between the how it is flowing through a homogeneous and saturated horizontal soil strip of 10 meter length. So in a lengthwise it is flowing. Okay. So this is maybe 10 meter of the soil, and the strip is being subjected to a constant water head of 5 meter at the beginning. Means if the flow, I am considering that it is happening from left to right side. If it is happening from left to right side, then yes, Santu, that is in per meter only. Previous question you are asking about, right? They have asked centimeter per cube per second per meter. That is in per meter only. Per meter width, for the per meter width only, right? So here suppose it is 5 meter, and at the end how much? 1 meter at the end. So I can say that this is maybe 5 meter, and at the end it has 1 meter. 1 meter, right? As long as you have a equation for hydraulic head related to the hydraulic head, that is d square h by dx square with respect to distance equals to 0. This equation you can simply utilize to find out the head at the mid of the section, because from the initial to the end how hydraulic head is changing, that we don't know. So if you just simply integrate, even if I will not write down any constant, if you write it down, simply you integrate and solve it. This is quite simple question. Integrate, how much you will get? That is dh by dx is equals to some c1 constant you will get. Some c1 constant you will get, isn't it? Yeah. Okay. Then integrate one more time, then you will get the relation, that is c1x plus c2. Use the boundary condition which has given, if x is in the initial stage, for the initial one at starting stage, when x is at starting stage, your hydraulic head is 5 meter. So use that. If x equals to 0, h is 5. So put that, and you are getting c2 as a 5. How much you are getting? You are getting c2 value as 5. Then another one, when x equals to 10 meter, if x equals to 10 meter, then your head is how much? 1 meter, है ना? Then your head is 1 meter. Put the value here. For x equals to 0, sorry, x equals to 10, put that 10 here, then h is 1. So 1 equals to c1 into 10 equals to, sorry, c2 already we have calculated, which is 5, so plus 5, and c1 you will get how much? 5 minus 1, that will be minus 4, minus 4 by 10, you will get minus of 0.4. So c1 you are getting minus of 0.4, and hence your equation will become h, let me write down here, your equation will become h equals to c1 value you have got minus of 0.4x plus 5. Now find the at x equals to 5 meter. At x equals to 5 meter, what will be your h value, hydraulic head? Put that 5 10 kitna ho jayega, minus 0.4 into 5 plus 5, and you will get plus of 3. That's all. So 3 meter is the head. Next one, the average effective overburden pressure on a 10 meter thick homogeneous saturated clay layer is given. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by increasing the stress intensity from 100 kPa to 300 kPa. Okay. So the average effective overburden pressure on a 10 meter thick homogeneous saturated clay layer is 150 kPa, which is given. And actually at 150 kPa we don't know what is the void ratio. That is what he is trying to find it out. But somehow from the laboratory test we have an idea that when it is reducing from the void ratio, when it is reducing from 0.6 to 0.5, the stress intensity was increased from 100 to 300 kPa. You know that for the normally consolidated soil, Yes, it is for over consolidated, you'll get the curve, but for a normally consolidated soil you have a straight line, right? So the CC, the coefficient of compression index, that CC value does not get changed for the normally consolidated soil. Agree or not? So for the normally consolidated soil, first of all we will find out from the given value at that 0.6 to 0.5, first of all we will calculate the value of CC, that is coefficient of compression. So CC will be how much? Delta is the change in the void ratio, that is 0.1, divided by log of C2 by C1, sorry, sigma 2 by sigma 1. So log of sigma 2 is how much you have? Sigma 2 is 300 by sigma 1 is 100. From here, if you calculate what is the coefficient of compression index, that is CC, what is the value of CC you are getting it? What is the value of CC you are getting from here? 0.21. Now, as I told you, this is the one which they have observed from the laboratory test. So CC value is not going to change for the normally consolidated soil. And at 150 now, it is our duty to find out what will be the void ratio. So let us calculate at 150. If you will increase from 100 to 150, what will be the void ratio? So another time, once again you apply the same formula, that CC, which is 0.21 equals to. Now this time you are changing it from changing the void ratio from 0.6 to another level. That another level I don't know. That one we will calculate. Divided by log of 150 by 100. Log of 150 by 100. Now from here, if you will calculate, you will get the void ratio at the time when it was having 150 kPa of stress, right? The effective overburden pressure of 150 kPa when it is. Calculate the value of void ratio from there. So simply they have utilized the concept of compression CC value, right? And how much you are getting from that CC value? How much CC value you are getting it from? Oh, sorry, how much E value, that void ratio value you are getting it from here? 0.563. 0.563. What they have asked? The initial void ratio of the clay layer. That is what they have asked, isn't it? That is done. Now next one is very important and very fantastic, isn't it? Because see that settlement equation, the total consolidation settlement of the clay layer, the same question. Due to the construction of structure imposing on an additional stress intensity of 200 kPa. So the additional stress intensity, if you are going to impose that 200 kPa, he is asking what is the settlement. Now you know that what is the formula for the settlement. What is the formula for settlement? Settlement formula, can you tell me? CC by H naught 1 plus E naught log of, is it looking very weird? Oh. CC one plus E naught log of sigma 2 by sigma 1. Sigma 2 by sigma 1, isn't it? That sigma 2 is now what? Sigma 1 plus del sigma, and del sigma already we know that sigma 1 is what now? 150 kPa, hai na? 150 kPa, and del sigma we have already, he is saying that 200 kPa of the stress he is going to increase. 200 kPa, write it down there. Log of 150 plus 200 divided by 150. Now calculate it from CC value already we have, which is 0.21. H naught, the initial thickness 10 meter thickness already given. Let me write down all the values also. 0.21, just now we have calculated, right? Just now you have calculated. Oh, I am sorry, this H naught I have written at bottom. I'm really sorry for that one. Okay. Yeah, I got it. Yes, Santu, I got it. H I have written downside. So into H naught is 10 divided by 1 plus E naught. E naught also you have calculated 0.563 in the previous slide if you see. 0.563. So this is 10. This is 10.563. Then log of all this calculation, please do that. What is the settlement you are going to get? All of you, please don't forget to like the session, isn't it? What is the value you are going to get from here after calculation? This is going to come around 0.49. Yes, Santu, absolutely. 0.49 almost. Hence 0.5 meter. 0.5 meter. For a saturated cohesive soil, a triaxial test. This is once again a very simple question. For a saturated cohesive soil, whenever it is a saturated cohesive soil, and there is only one condition when you will get, phi 0 means no phi value, unconsolidated undrained test, unconsolidated undrained test. Quite simple one. Next one, you see a sample of saturated cohesionless soil tested in a drained triaxial compression test. For triaxial, for shear strength chapter, a few concepts, then along with that only two equations, right? Along with that only two equations. Whenever you are studying about the failure of the soil in a triaxial testing machine, so the failure plane, over the failure plane there is one formula, isn't it? Over the failure plane, that tau equal to c plus sigma tan phi something like. Then other than that, whatever the sigma 1 and sigma 3 is acting, by using that also you have another formula, that sigma 1 sigma 3 tan square alpha plus 2c tan alpha. These are the only two equations which will be generally helpful for solving any of the problem which is going to ask from the shear strength chapter, right? He's saying that a sample saturated cohesionless soil tested in a drained triaxial compression to show the angle of internal friction 30 degree. Phi they have given. Phi they have given 30 degree. The Davidic stress at the failure for the sample at a confining pressure is 200 kPa. No, he is asking the Davidic stress at a failure of the sample at a confining pressure. Sigma 3 they have given. 200 kPa. So one can calculate sigma 1 value, isn't it? One can simply calculate the sigma 1 value. What do you say? So sigma 1 value, how one can calculate the sigma 1 value? Sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. That is the only equation we are going to use. Sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha, where alpha is nothing but alpha is equals to 45 plus 5 by 2, isn't it? So alpha equals to 45 plus 5 by 2. So alpha you will get around 60 degree. 45, 5, 30 by 2, 15 plus 45, that is 60 tan square alpha. It is sample of saturated cohesionless soil. So C is already 0. C is 0. No cohesion. So C is already 0, isn't it? Then sigma 1 if you will calculate from here, how much you will get? That is sigma 3 is 200 multiplied by tan square alpha. Tan 60 degree root 3 square 3 to just 6. You are going to get 600 kPa. This is your sigma 1, but this is not the Davidic stress, right? The Davidic stress is the stress which is you are applying over your confining one, over your confined. So subtract the confined one. 600 minus confined one is 200, you will get the 400, right? So Davidic stress will be 600 minus 200. The confining one, if you subtract, you will get that 400 kPa. That's all. Next one. In a drained triaxial compression test, a saturated specimen of cohesionless sand fails under a Davidic stress of 3 kgf per centimeter square when the cell pressure is 1 kgf per centimeter square. The effective angle of shearing resistance of the sand. He is asking about phi value. Now, once again, same equation you are going to use, isn't it? Once again, same equation. What do you say? What happened, Varun? Why you are saying sorry? So here, Okay. Divitric is given, confine is given, so sigma 1 value will be 3 plus 1 4 and sigma 3 is 1, that's all. Now you know sigma 1 and sigma 3 is talking about drained triaxial compression saturated specimen of cohesionless sand. See, there is once again cohesionless sand. Cohesionless C is 0. Once again I will be using sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. No need to write it down. C is 0, no need to write. 2c tan alpha will be okay. Then sigma 1 and sigma 3 also you know that is 4 and 1. 4 and 1. Tan square alpha you can calculate, no? So alpha value, can you tell me how much you are? Tan square alpha equals to 4, tan alpha is equal to 2. Alpha value, if you calculate from here, how much you are getting? Around alpha value, I have calculated. Where is that one? How much alpha value you have? Okay. Alpha, you are getting 63.43. 63.43. Now he's asking about the phi. Alpha is equals to 45 plus phi by 2. So this is 63.43 minus 45 multiplied by 2. That's all, no? Phi, how much you are going to get? Almost around 37 degrees, isn't it? Almost around 36.87, which is 37 degrees. The contact pressure, several times it has been asked in different type of examination already. The contact pressure for a rigid footing resting on a clay at a center and edge are respectively. See, for a rigid footing, just you remember one thing at least. If you have a rigid footing, the settlement will be always same. Settlement will be always same. It is whether edge side or on mid of the footing, at mid of the footing. Settlement will be always same. So rigid footing is asking about the pressure. Is asking about the pressure, the contact pressure. Over the clay, the contact pressure will be, so this is your rigid footing. And for the rigid footing, settlement, as I told you, it will be same, only the contact pressure will be different. Only the contact pressure. Over the clay, the maximum contact pressure will be at the edge and the minimum contact pressure will be at mid of the footing. Whereas for the same rigid footing, if it is resting on a sand, if it is going to rest on a sand, still the settlement will be same, but the pressure, settlement will be same, but the pressure will be maximum at the center. This is for when it is going to rest on the sand. For the rigid footing. So it will be minimum at center and maximum at the edges. That is correct. Minimum at the center and maximum at edges. Yes, Shubham Raj, absolutely correct. अर्थ प्रेशर का देखा था मैंने, एक दो क्वेश्चन था, पर टाइम के हिसाब से मुझे लगा नहीं इतना सारा हो पाएगा. अभी भी क्वेश्चन तो है ही. Circular raft foundation of 20 meter diameter. See, this is very nominal question. You can see that there is only, that settlement has a, we are actually studying three type of settlement. This one I'm not going to solve it. Please do consider there is only one formula for that one. So that elastic settlement, when you are keeping your footing, right? When the load is going to come over the soil, there will be your elastic settlement, and already you have the formula that related to Poisson's ratio and Young's modulus. Use that formula 0.8 multiplied by some q divided by 1. That formula by use. Then you have a primary consolidation and secondary consolidation. This one you please do it. The ultimate bearing capacity of soil is 300 kilonewton per meter square. The depth of foundation is 1 meter and unit weight of the soil is 20 kilonewton per meter cube. Choosing a factor set 2.5, the net safe bearing capacity. They have given the ultimate bearing capacity. So from ultimate bearing capacity, you can get the net ultimate bearing capacity, isn't it? 300 minus gamma d. 300 minus gamma d. Where is gamma? 20 kilonewton cube. And where is d? depth of foundation is 1 meter, so 20, 300 minus 20 you will get, correct, no, 300 minus 20 you will get 280. Then Q net safe is asking, Q net safe is simply QNU by factor of safety, that's all. So 280 divided by factor of safety 2.5, and you will just calculate, you will get the value. Kitna jayega? 280 by 2.5, 280 by 2.5, how much you are getting? 112, that's all, 112. Two footings, one circular and other square, are founded on a surface of purely cohesionless soil. The diameter of the circular footing is same as that of the side of the square footing. The ratio of their ultimate bearing capacity. So as per Terjagi, this is first of all for the cohesionless soil, right? This is first of all for the cohesionless soil. Generally it is, we are remembering for the cohesive soil. So purely cohesive soil, your C value, NC, N gamma, NQ are where, you know, generally we are remembering. Now for first of all, if you write it down for the circular one, or how they have asked, first circular, then footing of circular and the square. Okay, for the circular one, what is the bearing capacity formula? That's all. What is the bearing capacity formula? So for circular Q, U, I'll write down C here, right? For just for identify circular one. C and C plus, you know, there is no meaning of writing down C and C. C value already is 0, no? Plus gamma D NQ. Then once again, gamma D, that is the depth of the foundation. C and C plus gamma D NQ. Depth of the foundation, he is keeping the footing over the surface. On the surface, there is no depth of footing. So that is also not necessary. So what I am saying, that C and C plus gamma D NQ, they are not at all necessary. Only, and one more thing, it is a circular one. Here you will get 0.3, that is 0.5 multiplied by 0.6, your shape factor. Then gamma D N gamma, isn't it? Gamma D N gamma. Now here it is a circular one, so dia will be there into N gamma. Keep it as it is. Okay. Okay. So for the square footing also, if you will calculate for the square footing, how much you will get? The ultimate bearing capacity for the square footing, once again these two are not necessary, keeping over the surface, and there is a soil doesn't have a cohesion, so C will be 0. So simply 0.4 gamma B N gamma, right? Gamma B N gamma. Gamma B N gamma. This is N gamma. Please consider that. Now see, ratio, if you will take gamma D N gamma 0.4 gamma B N gamma, the dia of that footing and width of that footing, both, if they are saying in the question, it is same. See, the diameter of the circular footing is same as that of the side of the square footing. If both are same, what is the ratio you are going to get? That is 0.3 by 0.4, or you can say that it is simply 3 by 4. That's all. So thank you all of you. These are the just few questions, and you have a question from stability and lateral earth pressure chapter also, which you have to see, but only 1 or 2 questions will be there. So simply the conclusion from all these particular questions which I have solved here today, if you'll see and if you'll go back and if you try to analyze it, they're asking from each and every chapter. So if one cannot say that is there some favorite chapter, all? No, not at all. They're asking the question from each and every chapter, very, you know, equally distributed from all the chapters. That's all. So keep it up, study well, wherever it is needed. We will be there. All of you, please take care. Thank you everyone.